So I'm going to that's an OCaml part 2. What is OCaml? Yesterday I started figuring out how to compose your own type. I'm just going through their documentation, and in general I don't like it because for example, Rust documentation provides clear path for you. That means you can learn the language, everything about it easily. But OCaml isn't like that, unfortunately. And I have extremely terrible internet connection. So I'm going to publish this video later, probably on YouTube. Anyway. Maybe my internet connection was so terrible because I know. No. Fine. So what is OCaml? Done. I'm trying to update stream info, but it doesn't want. Who cares? Last attempt and what is OCaml? Part 2. Please. Yes. Whew. That was hard. So now I can switch to OCaml. And I was somewhere here. UTop is their REPL. UTop. No. just an alt tab. So let's try color equals red, green, blue, yellow. Nice. And that's probably a closure. At least that's a function, and we can see here is it. Let me try let example c equals match c with red, rose, green, grass, blue, sky. Just wondering why the REPL doesn't support formatting. Banana. Unbound construction. Typo. Okay, that's oh, that's terrible. I should be more attentive to details, because I got error, syntax error, and I just didn't notice that. Terrible. Okay, house. Okay, next. Yay. And if I call it example red, I get rows. So this is where I finished yesterday, and I'm ready to continue. So notice the type of the function includes the name of our new type color. We can make the function shorter and its parameter C by using the alternative function keyword. Nice. Which allows direct matching. Oh, that's some kind of black magic. I feel like magic. Example equals function red, rose, green, Works the same way. As for me, I don't feel that as very expressive syntax when you just remove parameter. For me, it's better when we have a parameter, and it helps us to read code. But maybe if you have to write functions like this one very often, and every time that's a matching thing, probably that's a better thing. You can match one or more than one case at a time too. Okay. Let rec is primary. That's something new again, and I have no idea. Just go to docs. Get started. I think maybe I started wrong, because, you know, I installed it. No, I wasn't wrong. Installer, I don't care about installing already. I just want to learn basics. Did it. What next? Contribute. No, I next step. Oh. Maybe. Okay, yes. I think I missed this part, so probably I have to go through it first. That's terrible. That's terrible. I missed this part completely. I think it was too late. I wanted to sleep. Just another excuse. This tutorial will walk you through the basics of OCaml by trying out different elements of the language in an interactive context. At the end of the tutorial, we consider briefly how to compile an OCaml program into a binary executable. You can follow along with a basic OCaml installation and describe. Alternatively, you may OCaml playground with no installation required. No, that's fine. Examples in this tutorial start with a prompt. Is that part of code? Yep. Running OCaml. So basically we use OCaml. I need to try it. Just OCaml. Oh. As for me, it's cleaner than UTOP. Maybe UTOP provides more, I don't know, information about time, or counts comments or counter. I don't think it's very useful for me at the moment, and this clear user interface looks better for me. Let's try. So comment first once in the top level, write your expression at the prompt, end it with 2 semicolons and hit enter. Sure, thank you. So again, 50, yay, 2500. telling you not only the value but also the type. So yeah, type is integer, int, and value. In this case, int for integer. Now let's see how it looks using utop. Oh, okay, the same. I don't want to use utop at the moment. Maybe later. Not now. You can type, copy paste the code examples into OCaml, and you can create a file saved with ML extension, load its content in the. I like it. But maybe later. Use. Hash use. Use a relative path that takes into account the directory you start at the top level in or user. Okay. Playground. Nice. Expressions and variables. In OCaml, expressions have types, and 50 multiplied by 50 is an expression that relates to the int type value of 2500. Other primitive types in OCaml include float, string, and bool. Yep, we figured it out yesterday. To avoid repetition, we can assign a name to a value using the let keyword. So that's that's not a variable. We just assign a name. I'm not sure. Maybe they say it's a variable or constant, but anyway, we assign some name. And x. That was pretty. When we type let x and enter, the REPL responds with the variable's value, showing that x now means 50. So x multiplied by x relates to the same answer as 50 multiplied by 50. It's important to note that unlike in imperative language, variables in OCaml are immutable. So that's a variable, that's immutable variable. I think that's a constant, but you can reassign it. I mean, using let, you can assign it again. Meaning, their value cannot change after assignment. Also, variable names must begin with a lowercase letter or an underscore, and they cannot contain dashes. Okay, that's fine. We can combine a variable declaration with an expression using let in. Okay, just wanted to try it. Let x equals 50. Sorry, in x and x. Okay, so we declared a variable with the value of 50, and then we evaluated an expression, and the returned value was from that last expression, not from kind of declaration. But x is 50, so it wasn't changed. They declare the variable x and assigns it the value 50, which is then used in the expression resulting in the value. Note that let in and let are two fundamentally different things. Let x equal 50 is a variable declaration. It assigns the value 50 to the variable x, which is bound in the top level. Let x equals 50 in is an expression that includes a variable declaration. The variable x is only bound within the expression. Okay. Yeah, I think here is my problem. I had another x above, so let's try with y, and y. Okay, yeah, that's interesting. So the scope of this variable is only inside this expression. Okay, that's interesting, really. As you can see in OCaml response to the first statement, no variable is bound. This is denoted by the dash. No, I don't get dash. Where is? As you can see in the OCaml response, the first statement is bound. Let z 50. Sorry. I know. I need to get used to let w 20 in. Okay, so this part on the left means it points to a variable if it is. Okay, that's interesting. I mean, it might be useful. We can define multiple values with their own names in a single expression using let-in syntax. Whoa. In, let be in, a plus b. Yay. So return value is of type int and equals 3, but it is not assigned, is not bound to a variable. This defines two variables a and b with the value of 1 and 2 respectively, and then uses them in the expression a plus b, resulting in the value of 3. It's important to know that this is just a single expression. The OCaml top level knows the expression isn't complete until it sees the double semicolon. Functions. Okay. I think that's must be very interesting, because what I have seen in the tutorial about types was so curious. The let keyword can also be used to define a function. Here it is. I suppose in case we get two identifiers, square, x, here two identifiers, this means we define a function. And this is its signature, so it takes int and it returns int, and that's the name. Square 1. Sorry. Oh, here is now I see why GitHub might be better, because it allows me to to return to the previous line, and I did it because here if I made a mistake I can't fix it. Okay, fine. By the way, neither of them has colors in my terminal. Another interesting thing is that I don't need parentheses. Yep, just as we can do that in Ruby. And sometimes I like it until it becomes confusing. This defines a function named square which has one argument, namely x, and its result is equal to the result of the expression x multiplied by x. The expression that defines the result of a function is called function body. Function body on the right. When we apply the function as square 50, apply the function. So they don't call them, they apply function. It relates to the function body of square where x is bound to 50. So we get a result of 50 multiplied by 50 and equals 2500. When using let to define a function, the first identifier is the function name, square above, then any additional identifiers are the different arguments of the function. In our example above, the square function has only one. Okay, I want to try two arguments and let area xy. I hope it works that way. No. Okay, let area xy. I think that's if that's not, yeah, no. Okay, area 50 60, sorry, 60. Oh no. I think it looks like function inside. I mean, this expression is the body of this function, but this function is body of this function. At least when I look at this signature and this, this arrow. Tin. Not sure for now, but let's look. Define a function. The first identifier is the function name. There's only one. In OCaml, functions are values, so the REPL responds to the function definition with, well, square. Where was it? Yeah, here it is. And the type int, arrow int, tells us that the function square takes an integer and returns an integer. Takes integer, returns, I don't know. Takes integer, returns integer, returns integer. A bit confusing for me, but it works. Okay. I really like to learn OCaml. I mean, it's so different from other languages that you have some kind of a shift inside your head. I like it. Here's a different function which uses the comparison operator equal to test whether a given number is even. Okay, so here another difference from C-like languages. They usually don't allow compare using one equal sign, because it might be confused assign or compare, but here they don't. That's interesting. Let square is even x, so function square is even, that takes one argument x, calls okay, so we apply function square. I think apply is from math, isn't it? I was very bad in math, so I don't even know how to say that in English. Okay, so we apply function square to x, or how to say correctly. We apply square, and we how to call that word is mod 2, so we divide by 2 and get the remainder, and check if it equals 0. Fine, so check it. Square is even 50. Yay, true. Square is even 3. False, yay. Sorry. Okay. Mistake. Note that the OCaml infer the type int bool somewhere here. Int bool, yep. It is very smart. Which means square is even is a function that takes only one integer value as an argument and returns a boolean value bool. The boolean operator and is denoted with 2 ampersands, and or is denoted with 2 vertical bars. Yeah. No surprises here. A function may take multiple arguments separated by spaces. This is the case both in the function declaration and in the expression that applies a function to argument. Yeah, so I apply, for example, square is even 250 or 2x. Nice, I like it. Some arguments again. Let ordered ABC equals A, B, and B. Ordered 1, 2, Bill. False. So we can work with floating point numbers too, but we must write plus dot instead of just plus. This way we show the compiler that work with the floating point number. Yep. That's, again, as I said yesterday, I feel that OCaml uses weird ways to express some things. For example, two semicolons or difference between semicolon and comma in the same place, or like just adding a dot. That it might look like I don't know, not very friendly for people with not very good vision, for example. As I said, even for me it's sometimes a bit challenging to notice that dot. And when I say even for me, I don't have an ideal vision, but I did correction, so it's not the worst. Okay, let's try the example with this average, and they didn't explain this. They didn't explain this thing. Huh. I think that means, no, I don't know what does it mean. It's not int, array? Is it array? Or just any? Oh yeah, maybe that means any. Okay. A plus dot B divided dot by 2.0 float, nice, and average 5, 6. Okay, sorry, sure. Average 5, 6. 5.5. What I like here that it suggests, first of all, the error message is pretty clear. This expression has type int, but an expression was expected of type float. And hint, did you mean 5 point? Yeah, I think it's pretty clear, and suggests, at least for this case, that suggests a pretty good option. This is rather unusual. In many other languages, such as C, integers get promoted to floating values in certain circumstances. For example, if you write 1 plus in C, the first argument, which is an integer, is promoted to a floating point number, making the result a floating point number too. OCaml never does implicit typecasts like this. The OCaml 1 plus is a type error. The plus operator in OCaml requires 2 integers as arguments, and here we give it an integer and a floating point number, so it reports this error. Oh yeah, OCaml doesn't promote integers to floating point numbers either, so this is also an error. Yeah, I like. I see very good suggestion here, but nothing for the first. Let me try. 5. Sorry. Okay, yeah. Probably because it can suggest fixed for values in the expression, but for the operator, or maybe it's too many, because we need to change the operator from plus to plus point, plus dot, and also we need to 1 dot, the value change, and maybe that's completely inappropriate, because we change the type of the operation, the resulting value, and yeah, so because in this case, when we use 1 plus dot 5, it's pretty clear that we want to get a floating point, so we can just fix one value. Nice. What if we actually want to add an integer and a floating point number? Say they're stored as I and F in OCaml. You need to explicitly cast. So let one, and now I want to float of int I plus float of int. Float of int. Pretty wordy. The float of int oops. I'm still here. It was my wife. Okay. Float of int. No. I want them back. Thank you. So nice. Okay, go on. You might think that these explicit casts are ugly, time-consuming even, but there are several arguments in their favor. Firstly, OCaml needs this explicit casting to be able to work out types automatically, which is a wonderful time-saving feature. Secondly, if you've spent time debugging C programs, you'll know that implicit cast cause errors which are hard to find, and much of the time you're sitting there trying to work out where the implicit casts happen. Making the cast explicit helps you in debugging. Thirdly, some casts are actually expensive operations. We do ourselves no favors by hiding them. Yeah, I agree. Makes sense. Recursive functions. Nice. Let. Okay, yeah. Okay, rec means recursive. Oh, this is it. Let rec. This is why I started looking for a more basic description of the language, and here it is. Recursive. Rec recursive. A recursive function is one which uses itself in its own definition. And a OCaml function isn't recursive unless you explicitly say so by using let rec instead of just let. Here is an example of a recursive function. Let rec. If A more than B, then, sorry, hope I'm correct, else A, range A, oh, it becomes harder and harder. B, I don't understand what's happened. We get two integers and it returns a list of integers. If A more than B, we return empty list. Otherwise, okay, I think that's a merge operation. We merge two lists. Using this, what is the name for column? Two columns. I need to check it. Column. Yeah, two columns. Colon. Okay, let's try to apply it. Sorry. Let digits equals range 09 and we get a list here, list of integers. Okay, we've used OCaml's if then else construct to test a condition if then else, yes, and choose a path of evaluation. Notice that, like everything else in OCaml, it's an expression, not a statement. the result of evaluation, evaluating the whole expression, either the result of evaluating the then part or the else part. Nice. The only difference between let and let rec is in the scoping of the function name. If the above function had been defined with just let, then the call to range would have tried to look for an existing, previously defined function called range, not the currently being defined function. It sounds stupid, actually. Why I have to specify this recursive function to give it a chance to know that I want to use this name here? Why? I think in here I think other languages like C are more forgiving and more convenient. But maybe that's kind of a habit. Types. The basic types in OCaml are integer, 63-bit signed int on 64-bit processors, or 31-bit signed int on, I think that's because of signed, so 1 bit for a sign, and we don't have unsigned as I see. Float, IEEE double precision floating point equivalent to sys double. Bool, a boolean written either true or false, and char, an 8-bit character, so we can't use it for UTF, for Unicode. I mean, string, a string sequence of 8-bit chars. OCaml provides a char type which is used for simple 8-bit characters, written X. For example, there are comprehensive Unicode libraries that provide more extensive functionality for text management. Strings are not just a list of characters. They have their own more efficient, character. They have their own more efficient internal representation. Strings are immutable. When we type our expressions into the OCaml top level, OCaml prints the type. Yeah, we noticed that already. Sorry. Is it possible? I think just in case. Yes. So the problem was because of this space between, not because multiple semicolons. False. Care. For me, char is more convenient. Sorry. So char. And quote, help me, or string. Nice. Each expression has one and only one type. OCaml works out types automatically, so you will rarely need to explicitly write down the function type, but you can, I think. However, OCaml often prints out what it infers are the function types, so you need to know syntax for a function f that takes arguments arg1, arg2, argn, returns the red type. The compiler will print f : red type. The arrow syntax looks strange now, but later you'll see why it was chosen. Our function average, which takes two floats and returns a float has type. I still think that's because it is somehow nested, somehow kind of nested closures. The OCaml standard int of char casting function. I want to try it. Int of char. It takes integer. No. Int of char means, sorry. Okay. So int of, so that's a code. Okay. Int of char. I think it should be 20 for space. Oh, 32. Int of char. Illegal. Okay. Okay. Did you mean no? No. No. I didn't. Okay. Yeah. Stupid me. It says char and returns int. Now look at some of the properties that distinguishes OCaml from other languages. OCaml is a strongly statically typed language. This means each expression has only one type and it's determined before the program is run. Compile time, probably. OCaml uses the type inference to work out the types. So you don't have to. If you use the OCaml top level, then OCaml will tell you its inferred type for your function. OCaml doesn't do any implicit conversion of types. If you want a floating point number, you have to write 2.0 because 2 is an integer. OCaml doesn't know automatic conversion between int and floats or any other type. As a side effect of type inference in OCaml, functions, including operators, can't have overloaded definitions. Okay. Yeah, otherwise it's ambiguous. Pattern matching. Instead of using one or more if then else constructs to make choices in OCaml programs, we can use the match keyword to match on multiple possible values. Consider the factorial function. Factorial. Let's consider this factorial function, which is recursive. If n is less than or equals to 1, then 1 else and multiplied by factorial. Not sure why we need this parenthesis here. Maybe because n min. Okay, yeah, I understand. Now I understand. That's a single value, not like subtracting after calling factorial. But what's a bit, oops, sorry, no, who cares? Okay, I see. Then 1 else n multiplied factorial minus 1. Oh, now it works. Yeah. So for me, it was a bit surprising that we have space between function name and argument here, but actually these parentheses are just to group the expression and minus 1, not to show that these are arguments. Okay, nice. And what we want to do here, factorial 9. Cool. So, and now we replace it with match, with matching, pattern matching. Let rec factorial and equals, instead of multiple if then else, we use match with. Okay, so we use this vertical bars to, I don't know, to guard matching value for x. I need to get more explanation here. Sorry. Nine. Okay, 10. Cool. That's cool. Equally, we could use the pattern underscore, which matches anything, and write. Okay, I see. We just use the same variable here. Fine. In fact, we may simplify further with the function keyword, which introduces pattern matching directly. This is what I've seen here. And for me here, it was really confusing. Like, what? Where is our argument? Let's try it. Factorial equals function 1. By the way, why may I use here this syntax? Okay, I can't because I don't have this variable. Got it? Hey, unresolved error. If you're fine, then I'm not so okay, because I see unresolved error. Sorry, I'm not a very good in jokes. Kidding. Factorial. By the way, in OCaml, I'm not very good too. Now factorial 8. It works. That's great. I'm happy. We will use pattern matching more extensively as we introduce more complicated data structures. Oh yeah. Oh yeah. Lists. It's a common compound data type in OCaml. They are ordered collections of values of the same type. Yep. Just quickly. So what is the name for this sign? That's not a quote, or it's quote and this is a double quote. I need to check it. Single quote. Okay, I think single quote A means any. A list. I think that's just list of any values. And here that's a list of integers. And this, sorry, false, true, false, list of booleans, and list of lists. List of lists. Yep. There are two built-in operators on list. Yes, the two colon or cons operator adds one element to the front of a list. Oh. Only one element. I want to. Okay, yes, so there we had A, which was just a single value, and we had a range on another side. Okay, makes sense. Let's try it. 1, 2, 3, and the add operator, or the add or append operator, combines two lists. Yeah, so I confuse it with this one because looks good. Non-empty lists have a head, its first element, and the tail. So I suppose yesterday that list is not just a name for an array, that's a linked list, and I think that's true. Non-empty lists have a head, its first element, and this is why we have this head, and the tail, the list of the rest of its elements. But maybe I'm still wrong. List head 1, 2, 3, one, and list tail 1, 2, 3. Sorry. And what if I do that like 1, 2, 3 and head? Nope. So I should use list head for that. Okay, fine. We can write functions which operate over lists by pattern matching. Okay. Empty list, head, tail. No? Okay, let's try it. Let rec, so total L equals match L with 0 and h. This means we get the first element and yeah, so head and tail, but we use two operators, append list and what was another, cons operator. It's cons, adds one element to the front. So this is how we distinguish head and tail here. Looks nice. Total. And if I say total 1, 2, 3, where is, oh okay, that's stupid. Here it is, sum total thank you for following me. I think I don't deserve it actually. You can see how the pattern h colon t is used to deconstruct the list. Yep, naming its head and tail. If we omit a case, OCaml will notice and warn us. I want to try it. I can do it. Let rec total wrong L equals match L with H tail. Yeah, so we don't cover all the variants, and this is the option when we have at least one element for head. Total wrong T. This pattern matching is not exhaustive. Here's an example of a case that is not matched empty list. Yeah, so again I want to say that OCaml, at least REPL, I'm not sure how it is with the compiler, at least REPL provides very good explanation. Oh, by the way, that's just a warning, not an error. That's weird. I mean, I think in case of Go or Rust we get an error and it won't compile, and this one just a warning. However, I'm not sure how it works here in OCaml. Maybe we can compile with warning. Okay, thank you. That's interesting. We shall talk about the exception that was caused by our ignoring the warning later. Considering, oh yeah, I like it. Total wrong exception match failure. Nice. And this exception, at least it doesn't look well so clear. Probably it is better to fix all the warnings and not get this exception, because maybe in case we have all the code in a file and we run compile process, we get more information about that, like, oh yeah, I just missed this part. caused by our ignoring the. Consider our function to find the length of a list. Length match L with empty. This function operates not just on the list of integer, but on any kind of list, because it doesn't use the value. Yep, here we have used value, here we don't, and this is why it has this alpha list, pronounced alpha list. Alpha. I thought any list. For me, any list sounds better. Okay, no. This function operates not just on list of integers, but on any kind of list. This is indicated by the type, which allows its input to be alpha list. Length. Okay, I have to try it. Rec length L equals match L with empty list 0 and any value tail. Okay, yeah, we don't care about the head, just say one more element, and recursive call to length, providing the tail. Nice. Length, so we can 1 2 3. And what about just wonder if I can say ABC. ABC. Nope. List. Yeah, sure, thank you. It must be a list, but alpha list, so list with any values inside. The pattern underscore colon t, the head of the list is not inspected, so its type cannot be relevant. Such a function is called polymorphic. Here is another polymorphic function, our own version of the, what was the name? Append and cons. So our own version of append, operator for appending. Let rec append AB equals match A with B. Head tail and oops. I don't like this version of this function, because it uses another built-in function like double colon. What? We replace one using another function of the same level. I mean, but who cares? We just learn language. And I can use append, and here is one list, and here is the second list. Yay, it works. So happy. We're halfway through this tutorial, and actually I need to call to my wife right now. Muting. Okay, everything is fine. Just wanted to make sure they're okay. Okay. Let's continue. Notice that the memory for the second list is shared. But the first list is effectively copied. Such sharing is common when we use immutable data types, ones whose values can be changed. So B is shared. Is it correct? I suppose B is shared. Sorry. For the second list is shared, but the first list is effectively copied. Copied, shared. This is why we match through A and append to B. And okay, then I have to check. Oops, sorry. I have to check what is B now. Oh, stupid me. Let A equals 1. Let B equals, and now append A, B. Nice. A. So B. Huh. So we share. I think I'm seeing something stupid. Yep. Append T B. Return B. Case of empty A. We take H append it to a list. Okay. No, I don't understand. I don't understand. Let us write a function map that takes a function f and a list L. Map applies the function to each element of the list and builds a new list with the results. It builds a new list. Function list, thank you, match L with empty list for empty list and h head tail for function apply function f to the head and concat it with map f tail. So in this case we get a new list at the moment when we go through the elements, and in the end we have an empty tail and it returns an empty list, and then we start adding this head applied with function, and this is how we get the entirely new list. But in this case I was expected to get B, let's say, altered, because as it says we use this memory for the second list is shared, or it's shared just inside the body. I hope it will be clear later. Map total 1, 2, 3, 4, 5, 6, 3, 7, 11. Looks correct. And notice the type of the function f is in parentheses as part of the whole type. A returns B. Alpha list. So I think this called A, called B, like alpha and beta, and returns beta list. This map function, given a function of type A returns B and a list of A's, will build a list of B's. Sometimes alphas and betas might be alpha and beta might be of the same type, of course. The function map is a higher order function since one of its parameters is a function. Nice. Oh, here is a new syntax to define function. Map fun. It's fun. I hope it will become easier for me after some time. 2, 4, 6. Okay, 2, 4, 6. Reasonable. Just wonder if it is a kind of a short syntax for functions, like one-liner. I think syntax fun arrow is used to build a function without a name, which we'll only use in one place in the program. We can apply a function by providing only some of its arguments. This is called partial application. Apply a function by providing only some of its arguments. This is called partial application, which is weird. I think I remember there was an error when I provided only one argument. Oops, sorry. Map fun x. No, I think I just int list. That's a function. Okay. Yes, that's exactly what I was thinking about. So this is why this is why we have this kind of signature. They're nested inside each other. So when I didn't provide the second argument, I got the internal part like this. I got this function, and let me do that. X map fun x divided by 2. I know. I forgot. Let x map, and I see it said something about yes. Now I have to provide a list. Yeah. That's so interesting. So each function has only one real argument and always return an expression, which is usually function. No, not usually. In case we have more arguments, that's always another function. Or if it is just expression, it returns the result. Sounds interesting. We can apply a function by providing only some of its arguments. This is called partial application. The value we get back from such a partial application is a new function that takes all the remaining arguments. For example, add AB, add, and we get the whole function. Let f add 6, so we always have 6 there for A. Look at the types of add and f to see what's going on. We can use partial application to add to each item of a list. Yeah, it might be really useful when, sometimes we write these closures specifically, on purpose, and we think every time how we should nest it. So, and here you just provide the list of arguments, and each argument is just a nest function. That's interesting. Can use partial application map at 6 1 2 3, yep, and so we capture this 6 and we use it every time. Indeed, we can use partial application of our map function to map over lists of lists. Where is the internal part? Map. One moment. That's hard for me. Map takes 2 arguments. First is function, second is list. If we remove list, okay, so for the first function, for the first map, we get the whole list. And the second map works. No, vice versa. So this will be used for individual elements of internal elements, and this one works for the whole list. So here we take list and apply this for each element. Yeah. That's challenging. For me, that's challenging, at least for now. But I like it. I think that's a different mindset. Just that. That's kind of a functional mindset. We've seen basic data types like int, and our first compound data type, the list. Let us look at 2 more data types of interest. First, we have tuples, which are fixed length collections of elements of any types. Of any type. So yep, we looked at it yesterday. But I had a question how I can access an element from a tuple. Notice, okay, maybe T like that. No. I don't don't remember if I found maybe t dot 0. No. Notice how the type is written. The individual types that take up a tuple are separated by a asterisk, a star. In contrast, a tuple value, the individual values are separated by a comma. Records are quite similar to tuples, but instead of writing their elements in a fixed order, they have named elements. Yes, I remember that from last day. Type person equals first name string last name string age and thank you. Oops. Equals Frank last name Smith, the age equals 40. Bam. Let S equals Frank. Surname. No, sorry, last name. I just don't really understand why. Oh, by the way, T. No. Maybe. How to access the element of a tuple. Pattern matching works on tuples and records too, of course. Nice. Our own data types. We can define new data types in OCaml with the type keyword. Read intersection, yep, here. Okay, let's check it one more time. Type color equals red, blue, green and yellow. Thank you. Let L red, blue, red. Val L is list of colors. Each type constructor, which must begin with a capital letter, can optionally carry data along with it. Okay, type color. So each of them is a constructor. I mean red, blue, green, yellow, RGB. I hope I'm correct, because nobody can correct me. Green, yellow, RGB of int. So that's a tuple. So we can provide a tuple. Yes. I see let L equals red, blue, and RGB with a tuple 30. Oh, so 25. I have no idea what is it. This variant expression is expected to have type color. Yes. Blend. That's because of my typo. Sorry. Let L equals red, blue, RGB 35 154. Nice. Data types may be polymorphic and recursive too. Here is an OCaml data type for a binary tree carrying any kind of data. Type A, alpha 3. It's correct to say alpha every time I see quote A. Leaf, nice, and node of A 3, alpha 3, alpha 3. Okay, I need to understand that leaf and node. So I think these compound types are more similar to enums. And okay, very similar. Okay, let T equals node, sorry, node leaf 1, leaf 2, node leaf 3, leaf 4, leaf. Node consists of 3 element of the tree and 3 again. Okay, so that's 3. That's 2 branches, left and right, and the value between them. But Why a leaf doesn't have a value? Maybe because that's just an example. I hope so. A leaf holds no information, just like an empty list. A node holds a left tree, a value type alpha, and a right tree. Now we can write recursive and polymorphic function over these trees by pattern matching on our new construction. Let's try. Let recursive total t equals match t with leaf just 0, node l x r, left actual value and right total l plus x plus total r. Rec flip t match t with leaf, sorry, it's the same leaf, but yes, node lxr flips everything there, yep. Recursive flip r x flip left. Let's try our new functions. Let all total t cool total. Let flipped flip t 1 2 3 4 4 3 2 1. Yeah. T equal, and this is a comparison because we don't have let. Flip flipped and true, they're equal. Cool. Notice that we don't need to explicitly free memory to such data structures when we no longer need it, because OCaml is a garbage collected language. It will free memory for data structures when they are no longer needed. In our example one, the boolean test t equal flip flipped has been evaluated. Structure flip flipped is no longer reachable by the rest of the program, and its memory may be used and may be reclaimed by the garbage collector. But I think it doesn't work in the REPL because, you know, we can use the value again and again. Dealing with errors. OCaml deals with exceptional situations in two ways. One is to use exceptions, which may be defined in rough the same way as types. Exception E. That's interesting. Exceptions. But this time it starts with the uppercase letter. Exception E2 of string. An exception is raised like this. Let f a b equals if b equals 0, then please raise exception to division by 0, else a divided by b. Cool. An exception may be handled with pattern matching. Try with it. Okay, I need to go to the restroom for a few minutes. For 1 minute, okay. Ready, steady, go. So they say I can handle it, but first I want to just run this function with 10 oh no, exception, division by 0, f10 2. Nice. Real world result. Okay, and now I try this with e2, ignoring the message, we just return 0. Wow. And maybe I think I have to return. That's matching, pattern matching again. Magic. When exception is not handled, it's printed at the top level. Yeah, I tested it already. The other way to deal with exceptional situations in OCaml is by returning a value of a type can represent either the correct result or an error. The result in the built-in polymorphic option type. Yeah, I think it's similar to an option in Rust, or maybe Swift, but it looks very similar to Rust. I mean, non-sum. Let's try type option non-sum of a. Let FAB without meaningful names for identifiers.
Вот. И желательно, помнишь, как мы с тобой снимали, когда типа этот от вас эти...
Without meaningful names, this code looks so weird and like, what? Let F8 be OL. Then none else. Oh, so it was defined by us, not by OCaml. Takes int and returns option of int, because that's how we said sum of alpha. We can use exception handling to build an option style function from one that raised exception, the built-in list find function, which find the first element matching a given boolean test. Let list find opt pl try song list find l with this is pretty weird for me. It takes a function and a list and returns an optional value. Try some. I think that's a construction. As an alternative, you can use an extended form of our usual match expression to match both values and catch yes. This is what I want to see actually. Match list find P L with v, some v, exception not found, none. Yeah, this version is clearer. I think I expected this version to see first, and then maybe the other one with try. Try wheel. Try. Oh no, that's my mistake. I just forgot this syntax at all. Okay. Yeah. Everything is fine here. Everything is fine here. Imperative OCaml. OCaml is not just a functional language. Oh, it was. I didn't notice that. It supports imperative programming too. OCaml programmers tend to use imperative features sparingly, but almost all OCaml programmers use them sometimes. If you want a variable that you can assign and change throughout your program, you need to use a reference. Here is how we create a reference to an integer in OCaml. Okay, just show me. Let r equals reference. Ref stands for reference. Oh yeah, that's terrible. Oh, and now we get Go syntax. This reference is currently storing the integer 0. Let's put something else into it. Assignment. Oh, now we have assignment. uint unit. And let's find out what the reference contains now. That's the referencing. Yeah, the references. So the colon equal separator is used to assign two references, and the bang operator the references to get the contents. References have their place, but you may find that you don't use them very often. Much more often you'll be using let in to name local expressions in your function definitions. We can combine multiple imperative operations. Where is this? We can combine multiple imperative operations with semicolon. Surprising me on each step. I like this language, really. A B equals let T. The referencing, yeah. In so we define T as a temporary variable, and it contains the content of A. Now A is now the reference. B assigned. And B we assign T Okay, I want to try just one, 2. I expect to get an error because it expects a reference, or maybe it will make a reference on its own. No. Ref 1, sorry, ref 2. Ref 1, sorry, let A ref 1, let B ref 2. Now swap A B swapped. Notice the function return type is unit. Yes, I noticed. I noticed it here. There is exactly one thing of type unit, and it's written let's empty tuple. I think the same as in Rust. We use unit to call a function that needs no other arguments and is only used for its imperative side effect. For example, print number. No. Print new line. So we can return unit and let me try it. Let print number, and we can take them, specifying print. Do we have a string of int and print new line print number 2? Nice. And we can look at the type of the built-in function print new line by typing its name without applying the yeah, makes sense. So we just get the function itself. This is why we see the definition, I mean signature. Unit takes unit, returns unit, and our print number function returns unit because the last expression here is calling this print new line function. Get it? We can look at the usual imperative looping constructs are available. Here's a for loop. Let table n equals for row equals 1 to n, do for column equals 1 to n, okay, the same size, do print string of int row print string done. So this is how we state and declare the end of this loop. Print new line, and we have to pass something there. Done. We don't put semicolon at all if it is the last expression before the end, like before done. Let table 10. Wow. Okay, that's interesting. We defined unit. So it's like get table 10 and move it to def null. Why not just say that? Okay, because I don't know, but the difference is that here we got this kind of return type, and here no. Here is a while loop used to write a function to calculate the power of 2 larger than or equal to a given number. Here is a while loop used to write a function to calculate the power of 2 larger than or equal to a given number. Let's try it. Let smallest power of 2x. Let t ref 1 in while the reference t while do. It's pretty normal. T assign the reference t multiplied by 2. Smallest power of 2. Power of 2. Smallest power of 2. But we actually larger than or equal to a given number. Okay, I was trying to understand if it makes sense. I mean, this function at all. Like find the closest power of 2 to your number. very useful. Okay, I want to finish this tutorial today. In addition to references, the imperative part of OCaml has arrays of items of like type whose elements can be accessed or updated in constant time. Nice. I've seen them yesterday when I was looking at types. And that's an assignment. Sorry. Of a value returns unit. Yes, and we substituted value, changed the value of the first element Records may have multiple fields too, which must be marked in the type. Mutable. Records may have mutable fields too, which must be marked in the type. For example, type person. Person was first name. Last name. Mutable age, and let function. We define function. Yesterday I had a lot of questions to this syntax because I didn't know how to define a function, and that was really surprising for me. So we have the same syntax as for arrays. I mean, for assigning a new value, age plus 1. Now birthday. Oh. So proud of myself. I did. Yeah. 21. Day 22. Great. Whew. The standard library. OCaml comes with a library of useful modules that are available anywhere OCaml is. For example, there are standard libraries for functional data structures such as maps and sets, for imperative data structures such as hash tables, and for interacting with the operating system. We use them by writing the module followed by a full stop, then followed by the name of the function. Here are some functions from the list module. List concat 1 2 3 4 5 5 6 7 8 9. Wow. Now list filter. Okay, I think that's a shortcut of that's a shortcut 1 4 20 10 9 2. So we get that's a partial application. So here we get view the function, and it has two arguments, and we provide only first one, so here on the left, and that means that the second argument must be on this side. So I mean the second is on this side, and the result must be true. 10 must be less than this, the second value. So no, no, yes, no, no, only we get only one value in the list. Yes, I'm so smart, so smart. List sort compare. I think okay, it takes function for sorting, and no, let's check compare first. Two values and returns int. I suppose it's like compare 1 to -1, compare 2 1. So that's a pretty standard comparison function. Okay, list sort compare, and 1 6 2 2 3 56, oops, 56 3 2. Nice. The printf module provides type checked printing facilities, so we know at compile time that the printing will work. Let print length s print f has I characters sorry s string length s. List 0 So that's an iterator. We provide a function print length and 1. Sorry, 1, 2, 3. Yay, cool. You can find the full list of standard library models in the manual. Nice. I think tomorrow I'll try to write something using file system maybe, or input output. A model from OCaml. Apart from the standard library, a much wider range of models are available through the OCaml package manager OCaml. Please note you must have OCaml on the computer to follow the tutorial moving forward. Not just the OCaml playground tool. For these examples we're going to use model called graphics, which can be installed with OCaml install. One moment. Exit 0. Okay, where it is? OCaml install graphics. I'm reading too slowly. I could write both of them. Yep. Brew install X quartz. Okay, no problem, dude. Yeah, OCaml looks very interesting and exciting. I don't know. It might become my hobby. Let's see. I mean, in many ways it's better than than Rust, because Rust is something similar to others. Go is similar to others, but OCaml, that's something new for me. That it's functional. Many years ago, I think 9 years or so, I wanted to learn Elixir. It was nice, but for some reason I stopped doing that. I mean, why it is downloading so long? My internet connection is just terrible, really terrible. Why? Please. I regret. Maybe we become old while waiting. That's not a joke. Not a joke. Freud. Why? Why is it so terrible? I'm almost crying. And that's a good time to change the tag for the stream from software development to just chatting, because there is no software development. Oh, but by the way, it wasn't development from the very beginning. I mean, I did something else, but not development. Learning. Maybe learning. What's wrong with you? I think that's a good point to finish. No, otherwise I'm afraid it will take too much time, and we still have a few interesting things here. We'll finish it tomorrow. Maybe try to write the simplest program. I don't know even what, and I'm not very good in thinking it up. But anyway, see you. Bye.